Okay, so for 21, it's asking for the z values given an area. So the best way to do this is to first visualize it. So I'm going to draw this out right here. Here we have a negative z, and here is the positive z. And this area right here is 0.901. So it's kind of hard to just calculate these two z values given this. So what we're going to do is we're going to get the area here and the area here, and then we're going to use our norm.s.inverse function on Excel to get our z values. So the first thing I'm going to do is do 1 minus 0.901, and that's because the area underneath the curve is 100% or 1. Since we're using decimals here. So when you do that, you are going to get 0.099. Now, since this area right here and this area right here is going to be the same, what we need to do is divide this by 2. So when you take 0.099 and divide that by 2, you're going to get 0.0495, and that's going to be the area underneath here and the area here. And that's because this value right here is these two combined. So when we divide it by 2, then we get this area and this area. Okay, so perfect. Now we can go on to calculate our z values. And to do this, let's say we want to calculate this positive z value right here. We have to remember that Excel calculates to the left. So if we want the value to the right, which would be this, we would have to use 1 minus. So that would mean we would have to do equals norm.s.inverse, and we would do 1 minus 0.0495. And I'm just going to point this out right now. The reason we use S is because we have a standard normal distribution. The S here stands for standard normal. So yeah. Okay, so when we plug this into Excel, we are going to get 1.65. This is rounded. Okay. And if we want to get this side, because Excel naturally calculates to the left, we don't need to use that 1 minus. We're just going to use norm.s.inverse 0.0495. And that's going to give us the same answer, but as a negative. So negative 1.65. And that would mean our answer is B right there.